I guess he's in quarantine, I guess.
Quarantine?
It's in quarantine like every other
He
week.
went to the grocery store, so he's quarantined.
Alright, so here we got, refer to the figure R in the first quadrant, region R in the first quadrant, enclosed by the x-axis in the graph of the function 4x minus x cubed. So there's my graph. With each base of delta x equals 1/2. So you divide it up into 1/2. So here's 1, 2, and here's 1/2, and there's 3/2.
Divide it. Every 1/2? Is that what that?
That's what it said.
Okay.
So it's 1/2, 1, 1 and 1/2.
Alright, so there's question 1. They just wanted you to draw it, divide it up into this rectangles. Alright. Number 2, sketch the rectangles and compute by hand the area for the left ram approximation. Remember, my equation here is f of x equals 4x minus x cubed. Alright? Yes.
3 equals 1/2.
So therefore, rectangles. I'm sorry, this would be.
It's been good enough for the past half. And then when I walked out there, it stopped.
So there's my left ram rectangles. Area of a rectangle is
Length times width.
length times width, so therefore my width is 1/2. So let's find my length using the left ram, starting at 0, would be
0.
at 1/2. That's going to be 2 minus 1/8, which is
15 over 8.
right, 15 over 8. Then 1 would be 3. And then 3/2.
Wait, what? Oh, wait.
6, yeah. 9 over 8.
Which would be 21 over 8.
Yes.
Okay? So now we get 1/2 times 15 and 21 is 36 divided by 8.
4. Not.
9 over 2.
Nine halves plus 3 is
15.5.
times 1/2,
15 over
15/4.
Wait a second. Oh, sorry, that's right.
Would everybody agree?
It's like 4 plus 9 is not 15.
Alright? Then next they want you to do mid-ram. So mid-ram is here. What are you doing, son?
I'm copying that sound that keeps going over and over again.
We don't need more of it.
Outside.
These are not pounding like they were earlier. Alright, there's our mid-ram. Again, my width is 1/2. So instead of using 0, we're going to use
1/4.
1/4. So 1/4 times 4 is 1 minus 1/4 cubed, which is
112. No. 130. Wait.
164.
Yeah.
which 1 minus 1/64 is
63 over 64.
alright. then we're gonna go midpoint again, which would be
3/4.
3/4.
3 minus 27 over 64.
Which would be
A bit.
12,
165 over 64.
is this 192 over 64 minus 27.
Wait a minute. I guess.
Yeah, 165.
Agree?
Mm-hmm.
The next one,
5/4.
5/4.
Fool. Fool.
125 over 64.
195 over 64.
And then the next one would be 7/4.
Whoop.
7 times 7 is 49 times 7, what is 7 cubed? 49, 28, 353?
343.
343.
343.
105.
105.
Alright, then we're gonna take 63 plus 165 plus 195 plus 105.
Mm-hmm.
528.
528
Oh, it's 8 1/4.
over 64
Yes.
times 1/2.
So that is 60. What's 8 times 8? It's 33 over 2.
33 over 4.
33 over 4?
Wait, well, wouldn't it be times 2? So,
Or would it be times 2?
oh, it would be 33 over 8.
Because you could take,
I already simplified this by multiplying by 1/2. So I got 264 over 64.
oh,
Does 16 go to 264?
No.
4 divided by 8. Yeah, it's 33 over 8.
What am I doing wrong?
Why
Yeah.
is it?
Because 8 goes into 264 33 times.
Alright.
Um,
33 over 8. Okay? Then they say number 4, do the right ram. So we're gonna do here, 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 and here. So now we had 1/2 times, if we put 0 in, we get, I'm sorry, not, if we put 1/2 in, we get
15/8.
15/8. Put 1 in, we get 3. Put 3/2 in, we get
21 over 8.
and put 2 in, we get
But wouldn't it be 0?
which would we get the same thing, 15 over 4. So using our RAM, you'll have to do 2 RAMs, right? One that will have volume, one would just be area, right? Remember volume is when we turn it, it's gonna be pi r squared, correct?
When it's cylinders, stacked up on each other?
Basically, yes.
Okay.
Then number 6, they say find the exact area by using the fundamental of calculus. So the exact area would be the integral from 0 to 2 of 4x minus x cubed dx. So we want to take the derivative. Derivative of 4x is,
Is the antiderivative?
yeah, the antiderivative, thank you, 2x squared. And the antiderivative of x cubed,
One.
X, X 4 over 4.
we put 2 in. 2 times 2 squared minus 2 to the 4th power over 4. 2 squared is
4,
times 2,
8,
8.
8 minus 4.
16 divided by 4 is 4. So my area,
Oh, whoops, I put 2 to the 4th, but it looked like 24.
Yeah.
So it was 24 before, and I was like, that is not 4. But that makes sense.
alright, so I'm very close. 8 goes into 33. 4 and an eighth. Alright, so I'm close. 4 goes into 15, a little bit less than 4. Alright, 3 and 3/4. So we're very close on all my rectangular approximations to the actual. Okay? Alright, next one is 9. Alright? Suppose that the integral from -2 to 2 f of x dx equals 4. The integral from 2 to 5 f of x dx is 3. And the integral from -2 to 5 gx dx equals 2. What is the integral of from 5 to 2 f of x dx equals -3? Is that true or false? True. Why?
Because you switched the 5 and 2, so it made it negative.
Alright, so we switch the limits, and we're going to switch the sign. So yes, that would be true. Letter B. Alright, the limit, or the integral from -2 to 5 of f of x plus g of x dx equals 9.
False.
Why would it be false?
Because 7 plus 3, because from -2 to 5, f of x is 4 plus 3.
Which is?
7,
Okay?
plus the g of x from -2 to 5, which is 2. So 7 plus 2 is 9.
So it is true.
It is true. Do we understand why it's true?
Yeah.
Make sure if you have a question you ask. You say no, Connor, or yes.
I said yes.
Okay.
I said yeah.
Letter C.
I just.
F of x is less than g of x on the interval of -2 to 5.
Well, that is false, because we
Incorrect.
just went through the other one.
Okay?
This 7 is
Seven,
not
yeah.
less than 2.
Correct.
So,
Number 12. The interval of 0 to 10 is partitioned into n subintervals of length delta x 10 over n. We form the following Riemann sums, choosing each c of k, c subscript k and the kth interval. Write the limit as n approaches infinity of each Riemann sum as a definite integral. So again, letter A.
Integral from 0 to 10, x squared dx,
X cubed, right?
x cubed, yeah.
Letter B, Connor?
Interval from 0 to 10, sine x dx, sine x dx.
Missed something?
Oh, x, sine x dx.
Okay. Grace, letter C?
Interval from 0 to 10, 3x minus 2 all squared dx.
You missed something?
Oh, and then, so it would be interval from 0 to 10, x in parentheses 3x minus 2, and then that squared dx.
Correct. Yes. Letter D, Caleb?
integral from 0 to 10, 1 plus x squared all to the -1 dx.
Correct. And And letter E, Ally.
Interval from 0 to 10, and then it would be pi times 9 minus sine squared of pi x over 10 dx.
Correct, very good. Alright, so we know how to do those. Number 12. We just did number 12, I'm sorry. 15. Evaluate the integral analytically by using the integral evaluation theorem, part 2 of the fundamental theorem. Alright, 15, the integral from -2 to 2, 5 dx. Alright, we sort of can do this without the integral, but if we did, integral of 5 is?
Y equals 5?
Oh no,
Oh,
it
wait,
was 5 times b minus a. So 5 times 2.
Well, what's the integral of 5?
Oh,
Antiderivative of 5?
oh,
5x.
5x. They're asking you to do it by -2 to 2 of 5x, which is 5 times 2 minus 5 times -2, which is 10 plus 10, which equals 20. Alright, what did I do? 15 through 31. Okay. 16. Let's do this. Let's have Grace, you do 16, Connor do 17, Caleb do 18, Kim do 19, and Allie do 20. I don't know if we get enough time to do that, so if you do it at your seats, and we just go through and get your answers.
You said 20 something?
Yes.
Is sine of 0, 1? Or is it -1?
Sine of 0, think about it.
Which is sine of 2 pi. So it's 0?
Yes.
Okay. Sine of pi over 4 is that 1?
What happened to your trig value, son? No, sine of pi over 4 is not 1.
I don't remember them.
Grace, you got yours?
Not yet.
Not yet, okay. Connor, you got yours?
Almost.
Caleb, you got yours?
Yes, I have 18. It's -16, isn't it?
No, not -16. Kim, you got yours?
Is it -4?
You have 19?
Yeah.
No. Ellie, you got yours?
I got 2.
Oh, I don't know.
2, yes.
Got mine.
What's yours?
0?
No.
No?
Grace?
Not yet. I know it's not that hard hardly having trouble taking antiderivative. I'm like so sleepy today.
Alright, how are you gonna take the antiderivative?
We have to figure out what function would like.
Well, with these here, you're gonna do just the opposite of you doing the derivative.
Yeah,
Alright, so you're gonna add one and divide by it.
okay.
So the antiderivative of 4x would be,
You said add one and divide by
right,
it?
add one to your exponent that you have,
Okay.
and then divide by it.
And the new exponent.
So your exponent here is what?
Your exponent is one.
So you add one to it, you get,
You get two.
and then you're gonna divide by 2,
Divide what by two? Divide
the
four
function by 2 that you have there.
So we get 4x squared over 2.
4x squared over 2, correct,
Okay.
which is?
That would be 2x. Wait, 4x squared over 2. So that would be 2x squared?
Correct.
Okay.
2x squared, correct. Caleb, you fix yours?
Is it 7?
No. Caleb, you fix yours?
I think it's 16.
16 is correct. Connor, you fix yours?
Is it square root of 2 over 2?
Yeah.
Square root of 2 over 2, yes. Zero, one. What's your antiderivative, Cam?
2s to the 4th minus 4s cubed plus 5x.
Okay.
Is it 3?
Yes.
Yeah.
What do you got?
42.
Very good, 42, excellent. All right, so let's go, all right, Grace tried 21, Connor 22, Caleb 23, Akem 24, Ali 25.
Is the antiderivative of 1 over x ln?
Correct.
Would I, so 25 I'm basically doing the same thing, right?
Should be.
Okay. So would I'd be adding the exponent to only the x, right? Not the,
Yeah, this one's a little bit different because it's composite.
okay.
Do 26 instead.
Okay.
For 25, would it be easier to bring the bottom up to the top?
That's what I really
To do a negative and then
Still a composite though. You could do that, but you still have a composite. we haven't quite learned how to do that yet, but
What would
you
you
can
do?
try it.
Would you, if we had to do it right now, would you multiply it out?
No, that doesn't make it any easier.
Or I mean, cube the inside? And then-
Well, 36 is a
that-
constant, right? So I can forget about the 36.
You can take out the 36, yes.
Okay, so.
There is a method to do it, but we haven't talked about it yet.
I'll just do another parenthesis for time's sake.
Connie, you got yours?
Mm-hmm.
What do you got?
Square root of 3?
No.
No?
Ken, you got yours?
Is it 1?
Yes. Caleb, you got yours?
Is it square root of 3 minus 1?
No.
Is it 3 square root of 3 minus 1?
No.
No?
Grace, you got yours?
Yeah, is it 2?
Very good, excellent. 2. Al, you got yours yet?
I have not gotten it yet.
The derivative of tangent is secant squared, right?
No. Oh, the derivative of tangent is secant squared, yes.
Which one was I doing again?
22.
Oh, that'd be why. I did 23, I think. Probably got that one wrong still.
What did you say it was?
Square root of 3.
Oh, yeah, you did 23. You did 22.
Wait. So, but isn't tangent of 0, 1?
Tangent 0 is not 1.
Oh, tangent of,
Pi over 4 is 1.
oh. So tangent of 0 is 0?
Correct.
Okay.
How'd you take the
Is
answer?
number 26 2?
26 is 2. All right, here, it's gonna be easier to combine these two together. So t times square root of t is t to the negative 3 halves. Right, because this is t to the first, this is t to the 1 half. You do t, when you multiply with exponents, what are you gonna do? Add them. 1 plus 1 half is 3 halves, and then you take it back to the top, makes it negative, right?
Mm-hmm.
Now you can take the antiderivative. I just need some markers that work. Antiderivative of t to the negative 3 halves is
2t, or negative 2t over 3.
No, to the 1 half.
the negative 1 half,
Oh, well, yeah, sorry.
right? So now you got negative 2 times 4 to the negative 1 half minus negative 2 times 1 to the negative 1 half. 4 to the negative 1 half is
1 over 2.
Agree? 1 over 2 times negative 2 is
Negative 1.
Connor, your voice is changing.
I didn't know this was any one.
Alright,
Yeah.
1 to the negative 1 half is
1,
times negative 2 is
2 to the negative 2.
times negative
Plus 2,
negative 1 plus 2.
1.
Answer is 1. Everybody good?
Wait, what was the answer to 21?
21 was
2.
2.
And 23 is 1?
23 was
Square root of 3.
square root of 3.
Okay.
Okay? Let's see.
Because tangent of the secant is
Alright, number 30, you want to use geometry to be able to evaluate these integrals. Alright? So let's have Grace and Connor do 30. Caleb and Akem do 31, and Al, you got the privilege of doing 32.
Okay.
Using formulas of geometry. Okay.
You draw yourself a picture. Remember we said the square root of a number minus a x squared is always a what?
Circle, no, sorry, half a circle.
Half a circle, correct. And how do I know what my radius is?
It's the square root of the constant.
Of the number,
of the
correct.
number,
So Grace and Connor, your radius would be,
2.
and Allie, your radius would be,
yeah. 8.
correct.
So, okay.
So Grace, what would your picture look like?
It would be a semicircle going, right?
Okay, and where would your semicircle be located?
It would be, it would start at 0 and then end at 2, right?
No,
Okay.
remember it's gonna be symmetric,
Uh,
so it would actually go here.
Okay.
Because your radius is 2, so you're gonna go 2 on each side. You're gonna go here, and you're gonna go here, this is -2, and this is 2.
Okay, that makes sense.
Would you also go up to 2?
And you would also go up to 2, correct? So if you're using geometry, what area form are you gonna use?
A equals
Maybe
pi r squared
Okay,
over 2, right?
Oh, this is.
Because it's a semicircle.
alright, but what do they want you to have the integral of?
It's from 0 to 2. Oh, square root of 4 minus. Oh, from 0 to 2.
So your area is what?
4 pi?
Agreed? And how much of it you want?
You want half.
Quarter of it?
Remember, this is half, you want a quarter of it, so it'd be what?
Pi?
Pi? Okay, Akem and, Caleb, what did you guys get?
40.
Caleb got 40, is that what you got, Akem?
No. It'll be 32 minus 8, right?
Most likely it's 32 minus -8.
Yeah.
Because -4 times -4 is 16.
Oh, and then, yeah, 40.
40, okay. And Allie, what did you get?
I got 32 pi.
And remember, you're gonna multiply it by 2. Get 2 on the outside.
Oh,
Wait a
darn it.
second.
So, okay.
Yeah.
So 64 pi.
64 pi, correct. Alright, so I would look at some of the other problems, look at your quizzes, look at your lessons, review for tomorrow's test.